A very, very, very common simplifying mistake that many students make is when they're given something with an addition or subtraction in the numerator and something in the denominator, and they see, oh, I've got a 6 and an 8, they want to go like this, and they want to say, well, this is a 3 and this is a 4, so this now is reduced. That is very, very, very wrong. And there's a couple of reasons why. So look at what the 6 and the 4 are doing. The 6 and the 4 squared of x are an addition or subtraction problem. But when you put something in a fraction, a top and a bottom, remember that's division. So you just used a division to simplify something that has an addition in it. Is division the opposite of division or of addition subtraction? Division is not the opposite of addition subtraction. So you can't undo add subtract with a divide. So we need to think about this problem a little bit more. So let's think about it. If we have 6 plus or minus 4 square root of x, think about the top. What do 6 and 4 have in common? Well, they both are divisible by 2. So we can factor out a 2, and now we'll have 2 times 3 plus or minus 2 squared of x over 8. Now, look what's happening right here. The 2 with that whole quantity, 3 plus or minus 2 squared of x, what is happening there? That's a multiplication. And a multiplication can be undone with a division. So now we can take this 2 and this 8 and divide them both by 2 and get an answer of 3 plus or minus 2 squared root of x over 4. So you can see that you can't just reduce the first term with the first term. You have to actually think about all of the terms at the same time, or think about factoring. So that's the long way to do it. The shortcut method of doing this, if you want to get quick, and we do need to be fast at this if we're going on to AP Calculus, is you want to think, okay, 6, 4, and 8, we need everybody to get divided by the number or nobody to get divided by the number. I call it the cookie principle. If you've ever had a bunch of kids, either everybody gets a cookie or nobody gets a cookie. Because if you give a cookie to 2 people and not to the third kid, somebody's going to end up crying. So everybody gets divided or nobody gets divided. That's the idea here. So when I look at 6, 4, and 8, is there something that divides all of those? 2. So everybody gets divided by 2 or nobody gets divided by 2. Let's try it with our next problem. 3 plus or minus 9 squared of 5 over 6. Now, remember also with square roots, insides go with insides, outsides go with outsides. So you would never try to use a 6 on the outside of a square root and divide it with a 5 on the inside. Those do not go together, okay? So we're going to look at the 3, the 9, and the 6. Is 3, 9, and 6, are they all divisible by something? Yes, they're all divisible by 3. Now, we're going to divide. What is 3 divided by 3? Does it disappear? No. What's 3 divided by 3? 1. 9 divided by 3 is 3, so we get 3 squared of 5. And 6 divided by 3 is 2. Everybody gets the cookie or nobody gets the cookie? Everybody gets divided or nobody gets divided? Let's try the next one. 15 plus or minus 20 squared is 7 over 35. All those outside numbers have to divide by the same thing. What is it they divide by? 5. So 15 divided by 5 is 3. 20 squared is 7. So 20 divided by 5 is 4 squared is 7. And 35 divided by 5 is 7. Now, we may see, hey, there's a 7 in the square root and a 7 down here in the denominator. Can I cancel those? No, you can't cancel insides with square roots with outsides. No, 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 no. Insides and outsides, there's a force field there. You cannot use them with each other. It doesn't work that way. All right, let's look at our last one here. 6 plus or minus 9 squared root of 2 over 4. Is there something that divides all of those? No, there is not. So this one is simple the way it looks. So this is our shortcut way of simplifying things that might come out of the quadratic formula.